and I can imagine as a product manager, the role is literally a bridge between these bespoke customer applications, pulling you in various directions, and you seeing how could I leverage of the platform that we've built.
Absolutely, and I think there's a few other dimensions to it, which again have been interesting and have provided a new set of challenges, which is the stakeholders. There's just a very wide range of stakeholders for what we do. So, for example, customers are one aspect of it. Absolutely, we've got our investors and so on, and any funding that we're managing and all of that. The other aspect to it is things like licensing. So the CAA, the Civil Aviation Authority, want to make sure that we're sort of compliant with all their requirements. Another aspect is the launch provider and their requirements. Interesting. There's lots of different dimensions of it and lots of different people to sort of constantly be communicating with. And I mean, I guess the interesting challenge for me is each one of those stakeholders cares about different metrics, are measuring different things. Some are most interested in safety, some might be more interested in return on investment, so on and so forth. So you've got to keep all these kind of KPIs in mind as you go through and understand who your audience are and which metrics to communicate to each of them when.
Welcome to Deep Dive, the podcast where we will explore the ins and outs of managing deep tech products. I'm your host Ravi Sundaram, and we'll be talking to product leaders about the intricate and innovative process of transforming cutting-edge science and technology into products that shape our future. Join us as we learn from these industry-leading experts on how to turn groundbreaking scientific discoveries into tangible real-world experiences. Today, we are joined by Mulham Terkaoui from Spaceforge to discuss the unique challenges of product management at the intersection of space technology and semiconductor industries. Mulham trained as an aerospace engineer with a focus on spacecraft engineering and has worked in the aerospace industry for nearly 6 years, starting in drones and robotics, helicopter and safety, and eventually moving into payload design and development. At Spaceforge, Mulham manages the development of all payload technologies from concept phase all the way through to testing and integration. Spaceforge is an innovative UK startup revolutionizing space manufacturing. This cutting-edge company aims to harness unique environment of space to produce high-quality materials impossible to create on Earth. We speak to Mulham about the difficulties of managing stakeholder expectations across these two distinct sectors of space and manufacturing, the impact of geopolitics on product development, and how to plan for uncertainty in such complex landscape. Welcome, Mulham. Really pleased to have you on the show, and I'm sure our audience is going to learn a lot from this conversation.
Thank you very much for having me.
Brilliant. We can jump straight in. Can you provide our listeners with a brief overview of what Spaceforge does and the specific challenges your products aim to solve?
Yep, absolutely. So Spaceforge is actually an advanced materials company. And what we're trying to do is manufacture high quality, as you mentioned earlier, high quality base crystals in space, and then bring those materials back to Earth so we can utilize them on Earth and sort of extract their benefits. Now, in-space manufacturing is actually nothing new. It's a concept that's been around for a very, very long time. It's actually been demonstrated, back in the 70s on the Wake Shield facility, and there's been many, many experiments on the ISS since that proved that crystal growth in space is actually much superior to that crystal growth on Earth. There's lots of reasons for that. I'm just going to give some top-level reasons here because I think they are very interesting. The first is microgravity. So on Earth, we just can't get rid of gravity. We try, but we can't. And sort of buoyancy-driven convective effects usually have a massive impact on those sort of processes of crystal growth, and that applies across lots of different manufacturing processes. And effectively, where that is a dial that you can't normally sort of tune when you're making stuff on Earth, but removing gravity from this equation opens up endless possibilities of new materials that you can make in orbit in a way that you just simply cannot make terrestrially. The example we like to give of that, which is not necessarily relevant, is something like aluminium lead. If you wanted to make an aluminium and lead alloy, it'd be very, very difficult to get a perfect mixture. In fact, almost impossible to get a perfect mixture if you try to mix those two elements terrestrially, just because of the density differences. taking that up to space, you can very, very easily get the perfect mixture and then bring that back to use it. Now, I don't know why you'd want to make an aluminium lead alloy in this particular case, but you can apply that to several other materials. The other key advantage of manufacturing in low Earth orbit or in orbit in general is the low contamination environment. So even though terrestrially we've managed to do wonders with our ultra high vacuum systems, those who work with them might recognize that you can get up to 10 to the minus 12 pascals, which is a very, very high value. However, even within that pressure, the partial pressures of that are very high in nitrogen, oxygen, those same elements that we find in air. Whereas the advantage you've got in space is even though the absolute pressures are probably about the same depending on your altitude in orbit, you can actually, the partial pressures are very different. Most of that is hydrogen, and unless hydrogen is a contaminant for your process, then the levels of nitrogen and oxygen are much significantly lower. Some studies suggesting something like 10 to the minus 33. So orders of magnitude better than anything we can do terrestrially. And then just the final point is that you get extreme temperatures. Just by pointing to cold space, you've got near absolute zero, and pointing to the sun, you've got plus hundreds of degrees. Again, another advantage you can take up by just simply making things in orbit. So that's a sort of overview of why you would want to do this sort of stuff in orbit.
This is already blowing my mind because many years ago I worked as a scientist, and ultra high vacuum is not unknown to me, and this just blows my mind. Perhaps we could give us an example of what, maybe not a specific material, but maybe an application which would benefit from this, because obviously you're sending materials to space and manufacturing, then getting back, you're adding cost. What sort of sector really benefits from this?
Yeah, absolutely. So lots of sectors actually. I'm going to talk about some of the sectors that are very interested, and then I'll talk about the sectors that we're focused in on Spaceforge. So there's obviously a lot of research that you can do. So lots of universities are interested in studying new science, discovering new materials, and so on. The pharmaceutical industry is very interested in that because you can grow complex sort of proteins in orbit that are undisturbed again by all the things we just mentioned. But the application that we're focused on in Spaceforge is compound semiconductors, effectively the base crystals of semiconductors that can be made with significantly higher qualities, offering sort of orders of magnitude potentially improvement in the sort of end application in terms of efficiency. And even looking at a simple application, so to be more specific, for example, if you looked at 5G towers, in the initial target for Spaceforge, if you can just simply replace the current sort of amplifiers and so on in those 5G towers with ones made in space, who've got much significant efficiency improvements, let's say on the order of 30%. That immediately is gonna reduce your running costs, reduce your CO2 emissions, and so on and so forth. So the sort of benefits are limitless, and we've already got partnerships with the likes of BT who are very interested in this sort of technology.
This is absolutely fascinating stuff because, again, coming from the compound semiconductor industry where we do things more, let's call it terrestrially, it's actually absolutely fascinating that there is a business case for this, and actually you're providing efficiency improvement and cost benefits to these industries. This is wonderful. Right. Before I jump into the rabbit hole of delving into the technology of semiconductors and so on, this is about product management in this space. So let's talk about that. When we spoke in the past, you mentioned that it's not very common product management in the space sector as a whole, as it is in the semiconductor industry. Perhaps you can, for our audience, you can articulate what your responsibilities are as a product manager in your role, and what are some of the reasons for this difference or absence of product management in this space.
So yes, to give listeners background, I started as a design engineer working primarily on the payload when I joined Spaceforge many years ago now, and since then I sort of developed into a systems lead role, and from there a product manager. And one of the things I noticed is, as a product manager, there's still a lot of systems activities that form a big part of my role. So the role does tend to be very technical, and there's lots of reasons for this. I mean, generally speaking, space companies that are trying to that have sort of customers that are not in the space industry. So, for example, I mentioned BT earlier and so on. They tend to provide a service, right? So whether it's Earth observation for weather reporting, or whether it's GPS or satellite internet, as we've seen with Starlink um, and SpaceX and so on. Perhaps there's not that many providing products directly for terrestrial, is your word, users. Just a little anecdote on the terrestrial stuff is we have always found it interesting is that we've got, as part of our processes, we've got a huge terrestrial sort of process going on to get things up and running, to get all the right characterization and metrology and things we need to sort of measure the quality of our materials. And when we talk to our key stakeholders, perhaps ones who aren't used to working in the space industry, we always have to sort of make clear what we're doing terrestrially and what we're not. And there always gets a few laughs or saying, oh, this is the terrestrial side of the process and this is the space side of the process. But yeah, effectively, so we are trying to provide a product for all our customers who happen, most of them will be using it terrestrially. There are space applications for our product as well, but most of them will be deployed terrestrially in 5G towers and so on. That's kind of one of the reasons. Another is, and I think we'll talk more about that, is just the longer development time of the development cycle in general. I mean, we sort of talk about old space versus new space, and generally old space where projects used to take decades to launch and required significant public investment and so on. We've got now new space, things that are moving much, much faster, but still by sort of, if you compare that to tech or any software products that perhaps have a development cycle of a year or so, it's still much longer than that. It's probably still on the 5 to 10 year time frame to develop a product from scratch in space. So much longer development timeline and less of an opportunity to iterate, perhaps, to sort of improve the products as you would in the tech sector. That is changing. So we'll talk more about that later, but perhaps low cost access to space has meant that you can iterate through products much more quickly than you were before. And just one final reason I would say is that generally space products and services tend to be more bespoke to a customer. So it's very rare that you've got one product that is going to serve all your customers. Even with us, we're trying to make these materials in space, but all our customers have different requirements that we need to make sure that we're adhering to. So the product has to change to each customer effectively. And again, that's another thing that isn't as present in some other industries.
I think you make some excellent points there regarding what I've heard is the longer development cycles, which obviously requires a deeper technical involvement. And you also mentioned the diversity of sectors that might actually not be in the space sector as your customers. That involves stakeholders. We'll talk about that as well. But the last point that you made is really poignant in terms of the long development cycles that you mentioned, but also the fact that you don't have products that are just like the tech sector where you can serve a lot of customers. They tend to be quite bespoke, at least for the early adopters, but generally quite bespoke for each. And that brings a fascinating question, isn't it? How do you do product management and how do you do product strategy as such? Are there underlying themes that are at least common across these sectors?
Yeah, absolutely. I mean, one thing I would say about the kind of more bespoke product is it keeps our engineers very happy because they're
Of
constantly
course.
having to innovate, right? And I'm sure you can appreciate that. So it is really interesting. I think the strategy that I like to take is really take a step back and think about the core technologies that form the product and think through the things that are least likely to need to change for a given application. Now, obviously, that means that you need to have had lots of conversations with your customers to understand exactly what each of them wants. And you try and sort of think the Venn diagram of all these sort of requirements and where the intersections are, and really focus the development as much as possible on these core technologies that aren't going to change or are going to have less change over time. And then just really what it's come down to is smart design, understanding that I'm designing this part that is likely to change for, when we're targeting different applications. So how can I design it in such a way that it means that it's easier to change? It's going to serve as many of those applications as possible. So really actually involves, you've got to involve the engineering team with some of those customer discussions from the very beginning, so they have the bigger picture, so that when they're making these design decisions throughout, they've got that bigger picture in mind and a good understanding on what the customers actually want.
Oh, this is absolutely brilliant because it adds brilliant and challenging at the same time because not only is it deep tech in the sense of really trying to understand where your customers can use your technology, the technology itself, the way the technology used is actually varying across sectors. So you're actually doing second order thinking of how you can develop your platform technology that could work across sectors, and that's essentially how you get your product efficiency and so on. This is
So,
really cool, and the design thinking comes into that where you're trying to keep as much of the base uh, common across the platform, but seeing how you could make the bespoke elements easily interchangeable across various customers or various applications. Very fascinating, and I can imagine as a product manager, the role is literally a bridge between these bespoke customer applications, pulling you in various directions, and you seeing how could I leverage of the platform that we built with minimal or efficient design change across these sectors. Does that capture it?
absolutely, and I think there's a few other dimensions to it, which again have been interesting and have provided a new set of challenges, which is the stakeholders. For there's just a very wide range of stakeholders for what we do. So, for example, customers are one aspect of it. Absolutely, we've got our investors and so on, and any funding that we're managing and on all of that. The other aspect to it is things like licensing. So the CAA, the Civil Aviation Authority, want to make sure that we're sort of compliant with all their requirements. Another aspect is the launch provider and their requirements. And if you're launching from a different country, for example, then you need to make sure that you're compliant with all the requirements of the facilities and sort of countries and so on that you're launching from, while also being compliant with the UK and the CAA and where they're quoted. So it's really interesting. There's lots of different dimensions of it to it, and lots of different people to sort of constantly be communicating with. And I mean, I guess the interesting challenge for me is each one of those stakeholders cares about different metrics, are measuring different things. Some are most interested in safety, some might be more interested in return on investment, so on and so forth. So you've got to keep all these kind of KPIs in mind as you go through and understand who your audience are and which metrics to communicate to each of them when.
I think that's an absolutely actually in many ways a unique challenge. In most deep tech sectors, you've got multiple stakeholders. I think the diversity of stakeholders that you've mentioned here is even more complex. Given from what I've heard, you're going from the launch authorities to IP to various other sectors where you have to manage stakeholders. Um, uh, can you elaborate a little bit more on how you handle this and what sort of do you have a process by which you handle this various stakeholders?
Yeah, I mean, it's been a steep learning curve, and we've had to learn along the way, and that's been why the journey has been enjoyable. I mean, Spaceforge sits at a very interesting intersection between the space and the semiconductor industry, and I know we previously sort of touched on that, but um, those two industries are not strangers. They actually have a very intertwined history, right?
Of
As
course.
I'm sure people will be aware that the Apollo program was the original customer that sort of drove the semiconductor industry to grow to what we know it now. I would say they're perhaps not as intertwined as they were back then, but interesting sitting at the intersection because one of the things we've had to learn is that communicating with people from the so we like to say that the people who come from the semiconductor background usually think the space bit is really easy. The people who come from the space background usually think the semiconductor bit is really easy. And so it's been really sort of fascinating to go through this journey with all our stakeholders, really, with all their different backgrounds. So, like you mentioned, the CA, for example, you might have a lot more people who are familiar with the space side of things, but we might have to explain the semiconductor process and the chemical processes that are taking place, etc., in a bit more detail than we would have to explain maybe the propulsion system or so on. and vice versa, right? When we're talking to our semiconductor customers, usually it's very data driven. They want to understand things about the repeatability of our processes and so on and so forth. And so now we're in a much better position where we have a pretty good idea, and we've got people employed who've got backgrounds in both of those sectors who can help us tailor our communication as needed, make sure that when we're talking to each stakeholder, we're telling them exactly what they need to know. We're bringing the information that they need to know, and perhaps not talking too much about the stuff that they care less about. So, I mean, it's interesting you mentioned a process, because I think this is a process that we've had to develop as we go along. And tailoring that communication for me is really about doing a bit of homework to understand who you're going to be talking to before you do it. Understand what their backgrounds are, understand what they're interested in, and then make sure you sort of tailor what you do accordingly.
I think that's sage advice there in terms of you can't have a common first call deck that goes across across these different stakeholders. You got to speak to the audience given the diversity of technology there. And the process that you've employed is really to start with your customer or your stakeholder here, and then build the messaging for them, and then do that for your various stakeholders. That is very interesting, and I can see how that could be a challenging skill for a product manager to at least know the audience that you're talking to, and then bring in the right experts to go deeper when required. So
absolutely. And I think, like,
brilliant.
one thing to add is, we talk to the space people, and for example, they might be more interested in the vision or where the technology is going, or like, generally there's lots of people in the space industry with grand visions, and they want to know that. And then maybe semiconductor background people with semiconductor backgrounds might be more interested in scaling the process, and so on and so forth. And like I said, that more data driven approach. And once you understand these things, you can work with them. You can work with it much more easy.
Excellent. So yeah, look for the key data-driven KPIs that they're caring about, and align your value proposition to those, and that's where the conversation moves forward. Brilliant learning. Maybe we can pivot a little bit and speak about the other challenge in space tech that we touched on, which is dependencies, especially the dependencies as people like us looking from outside in, which is launch schedules, which is heavily dependent on your providers. Unlike traditional product launches where you control your launch window to some extent, obviously we're all trying to hit market timing. I guess in the sector that you're playing in, you really have to very precisely align your product readiness or your payload readiness in this case with really inflexible launch windows, and sometimes you're not in the control of your launch. So what sort of challenges does these tight windows pose, and how do you manage the risk and timelines?
Yeah, no, it's a really good question, and we've got another dimension again to this, which is the return window as well.
Of
So
course.
we've got the launch and the return to think about. And I mean, it's interesting because we've got a joke going that if you're a company that is trying to do anything that requires you to develop a launch vehicle, then you're a launch vehicle company. We are definitely not developing a launch vehicle, so we are absolutely dependent on those launch providers to help us get to orbit, and then from there we can start doing our experiments and producing our materials. So we had that sort of earlier in the year, I guess, where with the Virgin Orbit launch, was that last year? I think it was the Virgin Orbit launch that happened in the UK, and sometimes the launch windows, they get delayed. There's all sorts of reasons for that, all the sort of things that we mentioned earlier with the different stakeholders and so on. It's very hard to plan for these delays as well. We're fortunate to have a process that is not sensitive, at least from a technical point of view. It's not very sensitive to timelines in that way. So some of the payloads, for example, that go on rockets would have biological experiments and so on. They're a lot more sensitive to these sort of delays and launch schedules and so on. So we don't have that problem per se, but it is difficult to plan around different launch windows. One of the things that has changed in the industry significantly is the likes of SpaceX bringing a very regular cadence to the launch industry. So nowadays, you can be fairly certain that if you miss a launch window, that you can get another one within a few months. Something that we almost take for granted now, but actually never used to be really a thing of even a few years ago. So that is changing, and there's many more players in the market that are sort of coming in. So you can start to plan for some of those failures, and certainly when we're planning to scale to have a very regular launch cadence. So any delay in any one of those is not going to affect us as much. You can never expect 100% yield. We're never expecting, so even if we're targeting 12 launches a year, let's say, we're not expecting that all 12 are going to launch in return. But you can certainly start planning as you scale. You can start planning to if you miss one or two, it's not as critical. So things are getting easier. Obviously, with return, it's a little bit more complex. So we've got our own return vehicle that we're designing, but we're also working with partners who've got their return. There's again many players in the market now who are providing low cost access or attempting to provide low cost return from space. And so again, as more of those emerge, and as Spaceforge develops more partnerships, I think that will overall lower the risk of these kind of launch and return windows.
It's an absolutely fascinating dimension, which definitely doesn't exist in most other sectors, which is because of the complexity of launch and so on. But you're right. I mean, the coming of age of SpaceX and other such services really makes it interesting because you have almost a regular supply chain and a diversity of supply chain that is developing, which gives you many more windows that you can build into your risk management and pipeline and so on. So that's very interesting. And I was going to ask you about how do you think of scale in this, but you've very nicely articulated the fact that the services, the space services or the launch services and return services that are developing across the globe is really making that possible to do all of this at scale.
Yeah. And I think the geopolitics, which again we'll probably touch on later, but has helped in that there is a drive for sovereignty with a lot of in a lot of countries. So Europe, I mean, we've had the Ariane 6 launch just recently, which is very exciting. Like I said, we've had an attempt at the first UK launch last year. I'm sure there'll be more attempts coming up soon. SpaceX in the US and many other launch providers, Rocket Lab and so on. So there's this recognition that that sovereignty is important to have some capabilities when it comes to launch and return. Now we're seeing more and more of that, and I think that again is going to help provide that regular cadence.
Brilliant. We touched on geopolitics, so maybe we can talk about that in a bit more detail. You've already mentioned that the geopolitics has helped. Maybe you can share some specific examples of how these external forces have impacted your decision making or road mapping, and how do you incorporate this into your planning?
Yeah, I mean, it's difficult to plan for these big shifts. Absolutely. I think so. My philosophy is you've got to look for the opportunities when these kind of big shifts happen. So let's just start with a few examples. It could go one of two ways. So with Russia's invasion of Ukraine, there was a lot of sort of skepticism from the European Space Agency about launching the ExoMars rover, something which had been in the pipeline for about 2 decades. So you can imagine, and that was designed to launch on the Russian Soyuz rocket, and then that was eventually suspended and then cancelled because that was no longer a viable option. And it's difficult to make these decisions. It's very tough. But I guess the flip side is it does provide a bit more opportunity. So with that came a recognition, like I said earlier, that perhaps having that capability in Europe, in the US, UK, so on, is really, really important. And so off the back of that, for example, the SpaceX Dragon capsule, and now we're seeing the Boeing Starliner and so on, are coming to life. Now they're providing regular access again to the International Space Station, regular return, and so on. And then for us, another interesting shift has been the kind of the semiconductor industry and the big changes we're seeing there, obviously, with the with the geopolitics of what's going on in Taiwan, there's been another drive to try and bring and onshore all these kind of key semiconductor manufacturing processes and so on. And so you can't plan for these things, but I think at Spaceforge we're developing two key capabilities, return and semiconductors, and I think we sit at a very interesting sort of intersection of these with the geopolitical things that are going on and so on and so forth. So yes, it has been a very interesting time for these two industries. Planning for that is difficult, but you've just got to find the opportunities where you can, where these changes happen.
A great example of leveraging the geopolitics and keeping your strategy agile to take advantage of the situation that we find ourselves in. This is really great. This has been a fascinating conversation. So I'd like to pivot the remaining time to really give our audience a little bit more learning from your experience. We've talked about stakeholder expectations and managing that geopolitics. We've talked about the long development cycles, which is a recurring theme in this sector. Any advice that you would give really people entering in this, particularly space technology, from a product management standpoint?
Yeah, I mean, a few bits of advice. The first is try not to get distracted. We talked about the long development timelines, and in that timelines, lots can change, and sometimes, change can be very tempting. Sometimes it is the right decision to do that, but I think really sort of taking a step back and understanding, the grass isn't always greener somewhere else. So, not, so really sort of being focused in on what you set out to do originally, really focusing on the things that are going to make the most impact to your technology over the long term is easier said than done, but it's really worth it when you get the payoff. So that's kind of my first piece of advice. The other one is don't try and do it all yourself. I think one of the things is, if you've got, for me, for example, my background is in aerospace, and it's important that I'm surrounded by people who really understand the semiconductor industry, like we talked earlier, understand those key metrics and can help me communicate those key metrics to the stakeholders who are looking for them. So really just making sure the right people are around you that are able to communicate to all your key stakeholders. Some level of change is inevitable with these timescales, right? I don't think, I mean, I don't know of any product manager in space, at least, that has developed exactly the product they had in mind when they started working on it 10 years before that. So I think, accepting that some level of change is inevitable, and really just making sure that your roadmaps allow for that. Don't make your roadmap too rigid. Make sure you've got regular reviews of technologies, of progress, of all of that to make sure that you've got the ability to adapt and pivot when you need to.
So many interesting points in terms of, yes, agility of your roadmaps, and we talked about the geopolitics, essentially being able to pivot based on the opportunities available, the focus to make sure that you're not changing for the sake of change, and I guess you do that by keeping a very north star of where you want to get to, and just keep moving in that direction. And so that is certainly some great advice. Anything else that you've learned? Any specific examples that come to mind?
I think, keeping the conversation open with your customers throughout is another important one for me, because again, it really goes back to those long development timelines where things change, technologies emerge, and you want to make sure that you've got an open line of communication with your customers where you are, again, reassessing at various stages and making sure any new requirements that they have are clearly captured and then implemented in the design process. Those are really my key bits of advice. I think
that's. I was just saying that's a theme that is coming across again and again in the space that I'm exploring, and almost turning your customer into a core development partner, if you want to stretch the term, because it's their requirements are changing along with yours, and you're kind of trying to develop a solution for their moving target. So that is absolutely a valid learning.
Absolutely. And I think when we're working with disruptive technologies, which, at Spaceforge, we're looking to create sort of big performance improvements, leaps that have not necessarily been made in that way before. I think sometimes it's important to note that the customers don't necessarily know exactly what they would want from, because it's a new product, it's never existed before. So again, it's another reason to keep those conversations open throughout, and make sure you're regularly reassessing, talking through the development, any changes, and so on.
How do you keep the team motivated and resilient through all of these changes, which are inevitable across the sector, but specifically in the space sector, it seems even more so. Uh, are there any techniques that you use, or anything that you
Yeah,
can share?
absolutely. I mean, I think we're somewhat fortunate in the space industry in that there's always this kind of grand vision that keeps, certainly I can talk for the technical team and so on, that keeps all our employees really, really excited by the idea. And I think really, for me, it's to never lose sight of that grand vision, and really make sure that everyone in my team understands how their piece fits into the larger puzzle. And as the puzzle is expanding, I want to make sure that they know about how it's expanding, and how they can contribute to that. So, like we mentioned earlier, there's a lot of bespoke products when you're working in the space. It's very rarely a single, one size fits all type situation. So that does tend to keep the engineers very happy. There's always more work to do. There's always more innovation. I think creating opportunities, like I talked about earlier, is really trying to see where those opportunities are and communicating those opportunities to the team, even when they don't all materialize. Just making sure the team is aware of the pipeline of work, and opportunities that are coming up. And I think there's two key points for me really working with my team is building trust is a really big one. I've always wanted, my team to be able to, any frustrations, anytime they need to vent, I want to make sure that they feel like they can do that, because change is frustrating. It's frustrating to all of us. I think
Absolutely.
that's a fundamental truth, unfortunately, and change is, like we said earlier, is really inevitable when you're working with these longer timescales. So it's really, again, open communication lines, making sure people know that you understand their frustration, you share their frustration sometimes, but really keeping that focus on the bigger picture. Is that, okay, things are changing, but actually we're still heading in that direction. We're just taking a slightly different route. Um, and I think lastly, really taking the time to understand what drives each of your team members. I find it difficult, when people are managing, say, 20, 25 people, it gets very, very difficult. So this is why I kept my team, who report to me directly, quite small, on the order of sort of 5 people, because I really like to take the time to understand um, what their challenges are, what their blockers are, what drives them, what interests them, what type of work they like most, and then making sure that I try and distribute the tasks as best that I can to suit their needs.
So brilliant. So focusing on the grand vision, which is probably why lots of your team members join the effort, which is a fascinating vision, and understand what opportunities and what drives these engineers and your team members. That really is the crux of kind of riding the waves of change and unpredictability that happens in many sectors, but certainly in your sector. That is excellent advice.
Absolutely.
Thank you for sharing that. Right.
Absolutely.
If we look forward, then any particular trend in your industry that you're particularly excited about, and how do you see those trends influencing your product management or product development?
Yeah, I mean, I think just looking at the industry, I think perhaps not many people are aware of in-space manufacturing as a thing. Like I said, it's a very old concept, but it's not necessarily um, very widespread knowledge of in space. People tend to think of the space industry and they think of the billionaire space race and space tourism and so on and so forth, which is a challenge for us,
Mhm.
because we're constantly trying to show that actually space is there to benefit humanity, there's a lot of opportunity for us to do a lot of good. So, for example, one of the things Spaceforge is we want to be the first net carbon negative space company. And the way we do that is with those materials and efficiency improvements that we talked about earlier, we can offset a significant amount of CO2 from ever being emitted, through these 5G towers and so on. So even when you take into account the launch and the development and all the CO2 produced throughout the lifetime of our satellites, um, we would still be a negative, not carbon negative space company. So I think I am really excited for all the trends in space manufacturing industry. So I think, like I said earlier, there's lots of opportunities in the pharmaceutical industry that are looking really promising. So whether it's drug development, whether it's sort of things like organ 3D printing and all sorts of bespoke medication, it's very exciting to see all the developments there, and just really the limitless possibilities. Like I said, we're focused on compound semiconductors, but manufacturing in space opens a door that with effectively limitless possibilities. I mean, if you look at the periodic table, at least theoretically, there's an infinite number of combinations of materials that you could make that perhaps you couldn't make before. So that's really what excites me. I'm very excited by the industry and where it's going.
Absolutely fascinating, and you're right. Like, I mean, it's endless possibilities there once you've got the process and the technology sorted. Which, by the looks of it, you're well on your way. It's going to be very exciting for various end industries to come take advantage of your services. Brilliant. Before we wrap up, I kind of like to ask my guests about their learning. So, any books or resources that you would recommend product managers or people in the space? Doesn't just have to be one, but anything that inspired you?
Yeah, I mean, I've got a couple of books that I particularly enjoyed reading. So the most recent one was Chip Wars.
Excellent.
People might be familiar with that one. That's been sort of top recommendation for a little while
It's
now.
it's on my bookshelf there, so you're not adding to it.
Amazing. Amazing. It's fantastic because I think the book does an interesting thing where it really talks about the politics of semiconductors as well, and the geopolitics of semiconductors. This is not just a technical or a historical account of the industry. It's all about the politics of the 20th century, which is absolutely fascinating. So I really enjoyed that read. Another one that's kind of one of my favorites from the space side is called The Right Kind of Crazy. And it's a book, I think it's Adam Steltzner and William Patrick, and it's about the development of the Mars rover, the Curiosity rover, specifically the landing mechanism for that. Again, it really sort of goes into the mindset of what it takes to do something that has never been done before, really from scratch, from first principles, and how you go about that. Yeah, fascinating book.
Oh, brilliant recommendations. We'll link to both of them in the show notes. Absolutely, definitely can speak highly of Chip Wars, and definitely will read The Right Kind of Crazy as you've recommended. Last question really is any trends outside of your industry that particularly is catching your attention or is interesting? Doesn't have to be for work, but in general.
Yeah, I mean, AI is now at the point. I'm sure that I'm not the first person to mention
Sure.
that by any means, but I think the kind of effect of AI, even in the last year or so that I've seen on productivity within my team, within myself, has been absolutely fascinating. It really is a big step improvement in a way that I hadn't seen before. So yeah.
Uh, can't disagree, and absolutely true. It's bringing some interesting angles of productivity that we never thought could exist. Certainly living in a wonderful time. Mulham, this has been absolutely fascinating. We covered a lot. And thank you for sharing your unique insight into this industry. You're certainly sitting in an industry such as the space sector, which is growing and bringing so many different applications, but also this intersection between space and manufacturing, semiconductor manufacturing has been absolutely fascinating. A lot of different trends that you expressed in terms of running products in the space. It cuts across various deep tech sectors, but there are some nuances that are specific to your industry, which is was very interesting to learn about, and I'm sure our audience will be learning a lot from it. So thank you very much for sharing your time. This has been great.
Thank you very much for having me, Ryan.
If you like that conversation, please subscribe. You could also engage further by joining the deeptech.syndicate Substack and Slack channel via the link in the show notes. You'll be tapping into a network of the brightest minds in deep tech product.